Okay, so we're going to be talking about logical equivalencies. I would highly recommend you watching my video on truth tables before you watch this video. So let's talk about the following definitions first. Two statement forms are called logically equivalent if and only if they have identical truth values for every single possible substitution of statements for their statement variables. The logical equivalence of statement forms P and Q is denoted by writing P and then the logical equivalent symbol, which is the 3 bars, and then Q. Now let's see how we can test if two statement forms are logically equivalent using truth tables. Okay, so this question says, determine whether the statement forms in 16 to 24 are logically equivalent. In each case, construct a truth table and include a sentence justifying your answer. Your sentence should show that you understand the meaning of logical equivalence. So number 16, the first statement form is P or P and Q. And then the second statement form we're comparing that with is P. So what you're going to have to do is you're going to have to create a truth table that includes these two statement forms as one of the columns in the first row. So first thing you should do when you are creating a truth table is you have to put down all the symbols. So we have P and we have Q. After that, we look at the next most basic component. So in parentheses, we see that there's P and Q, P and Q. And the only thing we don't have left is the P or P and Q. So we have P or P and Q. So we have P and Q, and we have P or P and Q. So there's only two variables, so we're just going to do true, true, false, false, and then alternate true, false, and then we have to compare P and Q. So P and Q is true and true, true, true and false, false, false and true, false, false and false, false. And then now we have to compare P or P and Q. So true or true is true, true or false is true, false or false is false, false or false is false. And then we're comparing P or P and Q versus P. And look at this, they have the same truth values. So all we have to write is same truth values. So the two statement forms are logically equivalent. Bam! That's it. Okay, so 17 says the first statement form is the negation of P and Q, and the negation of P and the negation of Q. And so we want to make a truth table in order to see if these two statement forms are logically equivalent. We first start with putting down all of the variables, just P and Q, so P, Q, and then the next most basic component are the negation symbols. So negation of P, negation of Q, and now we can look at the next most basic component where there are the and symbols connecting these two variables together and these two variables together, so we can just say P and Q, and then not P and not Q, and then not P and Q. Okay, so as you can see, as we write our columns, we get closer and closer to the two of these statement forms. Okay, so since there's two variables, true, true, false, false, true, false, true, false, 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 true, true, false, true, false, true, 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 true and false, false, false and true, false, false and false, false, and then not P and not Q, false and false, false, false and true, false, true and false, false, true and true, true, and then the negation of P and Q is false, true, true, true. Now you can see that these two columns do not have the same truth values. So we would say these two columns do not have the same truth values, thus they are not logically equivalent. There we go. Alright guys, so we're going to be doing another question that has us comparing two statement forms and seeing if they're logically equivalent. So number 23 says we have in parentheses P and Q or R compared with P and in parentheses Q or R. So in order to see if these two statement forms are logically equivalent, we first have to make a truth table. So the first thing we want to do is write down all of the variables. We have P, Q, and R. So P, Q, R. Then we would look at the next most basic component, and we see that in parentheses we have P and Q, and Q or R. And then we have all the parts except for these two statement forms as a whole. So we're just going to write P and Q or R, and then P and Q or R. And again, as you can see, as we look from left to right, we get closer and closer to the statement forms that we want. So since there are three variables, P, Q, and R, one way to write all the possible truth value combinations is for the first column, you write true 4 times. So true, 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 and then false 4 times. False, 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 false. And then for the second column, you write true, true, and then false, false, and then true, true, and then false, false. True, true, false, false, true, true. Yep. And then for R, you would just alternate between true and false. And now we're going to compare P and Q. So true and true is true. True and true is true. True and false is false. True and false is false. False and true is false. False and true is false. False and false is false. And false and false is false. And then Q or R, true or true is true. True or false is true. False or true is true. False or false is false. True or true is true. True or false is true. False or true is true. False or false is false. And now we have to compare P and Q or R. So true or true is true. True or false is true. False or true is true. False or false is false. False or true is true. False or false is false. False or true is true. False or false is false. And then now we have to compare P and Q or R. So true and true is true. True and true is true. True and true is true. True and false is false. False and true is false. False and true is false. False and true is false. And false and false is false. So because these two columns have different truth values, we can say that the statement forms are not logically equivalent. So you would just make an arrow right here and just write like a small sentence, something along the lines of, these two columns do not have the same truth values, so the statement forms are not logically equivalent. Oopsies.